All right, so good morning, guys, and welcome to what we'll call lesson 2, which is solving quadratic equations using square roots. All right, so yesterday we talked about how we can solve quadratic equations by graphing, right? And we remembered that the x-intercepts of the graph corresponded with what we'll call the roots, or the zeros, or the solutions, right? The answers to the equation. But another way we can solve some quadratic equations is using square roots, right? So ideally, in a few days, we're gonna get to solving quadratics by factoring, right? That's one of the biggest topics that we do the entire year. And factoring is really gonna be our go-to, right? So, if they ask us to graph, we're gonna graph it. If we have a really simple one, like the ones we'll see today, we use square roots. But in most other cases, we're gonna be doing factoring. And that's why we spent, a week and a half to 2 weeks on factoring, and we had that factoring test last week.
Good afternoon, everyone.
All right.
We've been notified that students...
All right, so let's start solving some equations using square roots. So if we're using square roots, we're basically going to want to isolate our variable term to the point where we have x squared by itself, and then we take the square root of both sides. We just have to remember that we can have a positive root or a negative root. So the first thing I'm going to do in this case is I'm going to add 16 on both sides. So that's going to give us x squared is equal to 16. We're going to take the square root of both sides, and I get x is equal to plus or minus 4. All right, so for today, I know we talked about using braces yesterday, but just in the interest of kind of saving some time, saving some space, I'm just going to keep the answer as is. They're all going to be in the form plus minus. So the braces for today maybe are going to be a little bit silly. So I'll leave it as x equals plus or minus 4, because obviously positive 4, if we go back to the original, positive 4 squared is 16 minus 16 is 0, and negative 4 squared is 16 minus 16 is also 0. For the second one, we're just going to have one additional step, because we've got a coefficient that's not 1. So I'm going to add 75 on both sides, which gives me 3x squared is equal to 75. We're going to divide both sides by 3, so x squared is 25. Now we take the square root of both sides. It's going to give me x is equal to plus or minus 5. Right, and again, guys, obviously I'm going through this kind of quickly because it's a little bit different environment than being in class and having people participate and being able to ask questions. So I'm just going to encourage you guys, if I go through it too fast, that you just pause it so that you have time to catch up. You can jot it down in your notebook. You can work the problems out on your own if you'd like. And of course, you shoot me some questions through Google Classroom, and I should be able to get back to you fairly quickly. All right, so this one, the procedure is going to be the same. Our end result's going to be a little bit different, right? So we're going to add 12 on both sides, so we get x squared is equal to 12. Now we take the square root of both sides, and I get x is equal to plus or minus radical 12. Right, so I'm okay with you leaving it like that, to be honest. We'll see how much we remember now, right? So back towards the beginning of the year, once we finished the equations unit, we did a little Pythagorean theorem. We did a little bit about simplifying radicals for this reason. So if you're doing this on the Regents and you see it's a multiple choice question and you get plus or minus 12, radical 12 is your answer, we would say, great, we take that answer choice. If it's a short response question, you can put that down and you'll get full credit. But if it's a multiple choice question and we don't see that answer, we're going to think about simplifying it, right? So the way we simplify a radical is we break it down into factors, one of which is a perfect square. So radical 12 we can say is going to be radical 4 times radical 3. The square root of 4 is 2, so we would say 2 radical 3. And we also want to bring down our plus minus. So we would say our value of x is it can be plus or minus 2 radical 3. All right, and then the second one is going to be pretty similar, except we shouldn't have to worry about that we shouldn't have to worry about the radical here. So I add 12 on both sides. I get 2x squared equals 72. I divide by 2. I get x squared is equal to 36. All right, we take the square root of both sides, and nice and easy, we get x equals plus or minus 6. And if we want to go back and kind of check it out, if I substitute 6 for x, I get 6 squared is 36 times 2 is 72 minus 12 is equal to 60. All right, so this one is just going to involve some fractions at the end. So again, guys, procedure will be the same. Right, I'm going to add 30 on both sides. It gives me 25x squared is equal to 49. I'm going to divide both sides by 25. Which should give me x squared is equal to 49 25ths. And now we take the square root of both sides, right? So the way and you can do this on your calculator if you want. It's just going to give you a decimal, and you can go to math and convert it to a fraction. But the way we take the square root of a fraction is we take the square root of the numerator, we take the square root of the denominator. So I take the square root of 49, which is 7. I take the square root of 25, which is 5. And we end up with our plus minus, right? So my solution should be x is equal to plus or minus 7/5. And I can essentially do the same thing for the next one, right? So I'll add 44 on both sides. So that gives me 81x squared is equal to 144. I divide both sides by 81. I get x squared is equal to 144 divided by 81. And I take the square root of both sides. I get x is equal to plus or minus 12/9. And if we want to be thorough, we can simplify the fraction to plus minus 4/3. All right, we can kind of skip over the first one. This really isn't any different than the rest of the ones that we've done. The second one is going to be very different, though. So this is where we're going to realize we've got a problem, right? So now I've got 2x squared is equal to negative 10.
Sorry for the interruption. Will the following
So that gives me x squared is equal to negative 5. All right, so now we're going to take the square root of both sides, but obviously we have a problem here, right? We can't take, at least not yet, right? Again, you'll learn this next year. We can't take the square root of a negative number, right? So if you put this in your calculator, depending on which calculator you have, it will give you a different type of error. The newer calculators will be very thorough. They'll say non-real solution. The really old ones are just going to give you some type of error. Either way, we can't do this, right? We can't, at least not yet, take the square root of a negative number. So I'm simply going to go with no real solution. And we saw that yesterday, right? Remember, we saw the graph that didn't have an x-intercept, and we realized that the equation, if we went back to the beginning, was not actually solvable based on our real number system. So it would be logical that there's no real solution, right? If we go back even and we look at this, right? How is 2x squared plus 20 going to be equal to 10, right? 2x squared is going to be positive, or perhaps 0 if x is equal to 0. But certainly adding something like this that's going to be greater than or equal to 0 to 20 isn't going to be equal to 10. The only way that would be equal to work is if 2x squared was negative 10, which doesn't work. So that's why we end up with, for something like this, no real solution. All right, if you want to work a little bit further, you can work on some of these, right? And then I'll be assigning some homework out of the workbook for tonight. And as always, guys, any questions or concerns, you shoot me a message on Google Classroom and we'll have a little discussion about it.